Okay, in this session, I'm gonna briefly introduce what is marginal benefit or marginal cost, and how do you calculate this economically. Okay, so the economic interpretation of marginal whatever is the additional whatever. Okay, so for instance, if it is a marginal benefit, then it is the additional benefit from consuming an extra unit of product. So this is just the incremental. Okay, so how do you understand it? For instance, if I'm consuming 100 units of products, like 100 units of sweets or candies, my satisfaction increases by 10,000 units. Okay, that's the consequence. And therefore, for each additional unit of product that we consume, it will bring to us 10,000 units over 100, which is 100 units of satisfaction. So this is how we understand marginal benefit from its economic interpretation. It's just an additional unit of the product in question. What is the consequence of either consuming it, if we're looking at the marginal benefit, or the cost of producing it, if we're looking at the marginal cost? Okay, all right? So the expression of this marginal benefit is then delta B over delta Q. As you see here, we are calculating for each additional unit of product its consequence on your benefit. So the consequence, which is the dependent variable, should be on the top. The cause, which is the independent variable, like the x, should be in the bottom of this fraction. Okay? All right. So that is the economic intuition part. And then let's turn to mathematics. Okay? If instead of a number is given to you, we have a function of benefit, like in this question, 40 q minus q squared, that is the expression, say, of the benefit. Okay? Then how do we work out the marginal benefit? We should use derivative. So please don't be afraid, okay? Don't be afraid. The derivative concept here, it is basically what we are doing as delta B over delta Q. All right? So delta B over delta Q, looking at this, what does this remind you? This looks like delta Y over delta X, isn't it? And this quotient of delta, okay, it actually means slope. And the derivative is to calculate the slope. It's the shortcut of calculating the slope. That's why we are using derivative. Or you may see derivative being put as d, okay, dB over dq like this. And here, I'll say it's just essentially the same as delta B over delta Q, in which we are replacing delta by a more mathematically sensible expression, which is d. And here, d stands for difference, which is essentially the same as what delta stands for, which means change. Okay, so here, dB, B is on the top. That means we need to treat B as Y. Q is in the bottom, which means we should treat Q as X. And here, we're deriving B with respect to Q. We're treating B as Y, we're treating Q as X. Okay, the two formula that we need to refer to are the following. I'm writing it down on the top of my paper as well for later reference. So first, if fx equals to x to the power of a, f prime x equals to a to multiply to x to the power of a minus 1. And second, if we are imposing our derivative to a multiplication, which is a constant multiplied to a function, the derivative is to keep this constant as a multiplier, multiplied to the derivative of this function. Okay, we only apply the derivative to the term that includes the unknown, the variable only. Okay. All right. So those are all the preparations. Let's look at the question. I'm gonna switch to my document camera. So as to show you how the problem is solved. Okay. All right. Here, I'm gonna copy down the problem. So knowing that BQ equals to 40Q minus Q squared and CQ equals to 20 by Q. Okay, and the question 1 is asked us to work out the functional expression of marginal benefit. So marginal benefit is delta B over delta Q, which is how many units of benefit changed per additional unit of product that you consumed. Okay, and here is dq over dB, right? And then we are working on the derivative of 40Q minus Q squared with respect to, I'm sorry, dB over dQ. And we are then working on the derivative of 40Q minus Q squared with respect to Q. This derivative. Okay, so here is the general function that then we can apply to. All right, so BQ is 40Q minus Q squared. Okay, let's look at these two terms. One is this, the other is this. Okay, so the first one, 4 by Q. Q is a function of itself, right? So here we are, for the first term, its derivative okay, the derivative of the first term should be applying the second rule. All right, so that is the derivative of 4 times Q. What's the derivative of that? It is 4 by derivative of Q with respect to Q. Some of you may already know that's the derivative of Q with respect to Q. That's like derivative of X with respect to X, which is 1. The result is 4. But here, in case that you forgot, then you're gonna, let's just utilize rule 1. In rule 1, it is Q to the power of 1, and we are looking at its derivative. That is, in this case, Q is the X, 1 is the A. So in this case, A equals to 1. Does that make sense? Okay. So the derivative of this is then we're moving A down here. Okay. And we keep this X, right? It's just 1-to-1 replacement. And then the power is A minus 1. Here, A equal to 1. So the power is, the new power is 1 minus 1. So it is 1 by Q to the power of 0. Q to the power of 0 equal to 1. So the result is 1. Okay. That's why the first term's derivative, 4q's derivative, is just 4 by 1, which is 4. Okay, now let's look at the second one. Minus q squared, we're taking its derivative. The derivative of this is, first, here we do have an a here. A is minus 1. It's minus 1 by q squared, right? So the derivative of that is minus by derivative of q squared. Here it's the same thing. For q squared, its derivative, okay? I'm putting the step on the side, okay? So in this case, we're applying the derivative of x to the power of a. In this case, q is x, a is 2. And its derivative is a to the power of x to a minus 1. A, we put it down here as the multiplier. And x, q is your x. And the new power is a, which is 2 minus 1. So here, right? That is 2 times of q. So here, the result is minus 2q. So marginal benefit is the combination of this two term, which is 4 minus 2q. 40, I'm sorry. minus 2q. That makes sense? Okay. So that's your question A. And for question B, that is to ask your marginal benefit when q equal to 2. So this vertical line means if q equal to 2. So we just plug this in. 40 minus 2 times of 2, which is 36. Which is 40 minus 4, 36. Okay? So now, let's move to the other side, which is marginal cost. Okay? So here, the cost function is 20q, and its derivative, which is marginal cost, that is 20 minus the derivative of q with respect to q, which is 20 by 1. That is 20 itself. Okay? And d, when q equals to 2, marginal cost, it is a constant. So that means no matter what number q is, your marginal cost is the same. Right? It's like producing each additional unit. This is what marginal cost means economically, right? The additional cost, the increment in your total cost by producing additional unit of product. So here it actually means producing each additional unit of product, the cost is the same, which is 20. Now let's look at the last one. How do you work out the Q that maximizes the net benefit, which is benefit minus cost? Okay, so here we can directly use the derivative that we have found in A and C and set them equal. So marginal benefit equal to marginal cost. That's when your net benefit is maximized. Okay, so marginal benefit is 40 by minus 2q, and marginal cost is 20. So here it is 40 minus 20 equal to 2q. I just move 20 to the left-hand side, change the sign, and minus 2q to the right-hand side, change the sign. So it is 20 equals to 2q. So the q star is 10. Okay. So here, just understand this intuitively. Okay. When marginal benefit equal to marginal cost, the net benefit is optimized. A little bit thing to understand here is marginal benefit and marginal cost. We are looking at we're looking at the two sides, right, of one thing, that is additional product. See, if I'm producing this additional pen, right, the cost is $5. The benefit is 3. Say, convert it into dollar value, $3. Should I produce it? No, because in that case, the cost exceeds the benefit. Not worth doing, right? If, on the other hand, if producing this pen, the benefit, again, converted into dollar value, is 10 units, $10. The cost is only 3. Yes, producing this unit of pen is profitable, right? Because benefit exceeds the cost for this additional one, but it doesn't mean that this is the best amount. It means possibly we can produce another pen, right? Maybe the cost will increase a little bit. The benefit will still be the same. See, producing another pen's marginal cost increases to $4, and the benefit on consumers is still $10. The additional pen is still beneficial to be produced for the society. So in that sense, we shouldn't stop at this current unit. We should expand our production until marginal benefit just equal to marginal cost. That's when your total benefit, total net benefit, is maximized. Okay, and this is one of the key conclusion that you should be looking at. And here, to relate a little bit to the forthcoming one, which is the second chapter, market, I'd like to foreshadow a little bit. Marginal benefit is the same as the demand curve, and the marginal cost is the same as supply curve. Okay, and this is easier to demonstrate as we're looking at this. Marginal cost, marginal benefit. Okay, so here, looking at this, it is the production at this level be beneficial to the society? The answer is no. The cost of producing that unit exceeds the benefit, right? So the production should not be here, say Q2. Q2 is not on the social welfare maximization point. And look at Q1. Yes, producing Q1 is beneficial because the benefit of Q1, right, exceeds the cost. But here, this is not the place where the total social welfare is maximized, because we can enlarge our production a little bit, but still be able to better off, still be able to see the marginal benefit exceeds the marginal cost. We're gonna keep expanding our production until this point where marginal benefit meets marginal cost just well. In that case, the total social welfare is maximized. Okay, namely the net social benefit is maximized. I hope this explains. Thank you.